These are the first of our trig properties. Properties are just mathematical equations that are always true for whatever value input that you put in, as long as it's defined in the function. We're already familiar with some of the trig properties. We've talked about them earlier in the unit. For example, you know the reciprocal properties. You know that secant is the reciprocal of cosine, so we can say secant of theta is 1 divided by cosine of theta. Cosecant of theta is 1 divided by sine of theta, and cotangent theta is 1 divided by tangent of theta. Get rid of my Java thing here. Because they are reciprocals, we know that they multiply to equal -1. So another way we could write them is to say secant of theta times cosine of theta equals 1, or cosecant of theta times sine of theta equals 1, or cotangent of theta times tangent of theta equals 1. So sometimes these serve as a way to simplify an expression by changing an expression of this sort to just 1. The second group of properties we're going to look at are called the quotient properties. So recall that if this is my angle theta, that sine would be y over r, and cosine would be x over r, and tangent would be y over x. Now I'm going to show you how sine and cosine are related to tangent in the quotient property. So what would happen if I took sine of theta and divided it by cosine of theta? Well, that would be the same as saying y over r divided by x over r. So if you have y divided by r over x divided by r, that simplifies to y over x. And if you're not convinced of that, think about multiplying the numerator and the denominator by the same thing. So let's say if I multiplied this fraction by r over r. So y over r times r would just give me y, and x over r times r would just give me x. So if I multiply numerator and denominator by this common denominator here, then we just end up with y over x. Well, of course, y over x is tangent of theta. So this leads to the first quotient property. Tangent of theta is equal to sine of theta divided by cosine of theta. There's the first quotient property. The second one, since cotangent is the reciprocal of tangent, cotangent theta is just cosine divided by sine. Those are the two quotient properties. The third group we're going to look at in this video are the Pythagorean properties. We will be referring to this drawing that we used for the quotient properties and these ratios that we used in the previous and that go along with this diagram. First of all, I need to make a correction right here. This is x squared plus y squared equals r squared. So if you look at this triangle up here, this is a right triangle, the Pythagorean theorem just says that x squared plus y squared equals r squared. I'm going to do a clever division now. I'm going to divide each one of these by r squared. So if you divide both sides by r squared, that r squared would distribute to both terms on the left-hand side and also divide the term on the right-hand side. Now looking up here, we see that cosine of theta is x over r and sine of theta is y over r. So x squared over r squared can be changed to cosine squared of theta. And y squared over r squared can be changed to sine squared of theta, and r squared over r squared is 1. So this is the first of the Pythagorean properties. Now when you see cosine squared of theta like that, that means the same thing as cosine of theta squared. Alright, so it means the same thing, it's just a more concise way of writing it. Also notice I'm not putting parentheses around the input value. If there's no parentheses around the theta, it is assumed to have a parentheses there. It's just a little bit more neat and easier to write when we're dealing with the properties to leave the parentheses off. So that's why I don't have them on there. Now, there are two more Pythagorean properties, and we get the second two by dividing the first property either by cosine squared or by sine squared of theta. So if we take the original property, so I'm going to rewrite it. I'm going to have to write kind of small to fit this on my screen, so bear with me on this. If I'm trying to make it as neat as possible. So if I take this entire expression and I divide everything by cosine squared of theta. So this is cosine squared, and this is cosine squared. So since I divided both sides by the same thing, the equation is still true. Now I can rewrite cosine over cosine as 1. Cosine squared over cosine squared is just 1. Sine squared over cosine squared, according to the quotient property, would just be tangent squared. So this is tangent squared of theta. And 1 over cosine squared, according to the reciprocal property, would be the same as secant squared. So we're using previous properties now and combining them together with the first Pythagorean property to get another Pythagorean property. So that's the second one. Now I'm going to rewrite my original property again. Cosine squared of theta plus sine squared of theta equals 1. And now divide everything by sine squared of theta. Once again, using the quotient property, the first term would end up being cotangent squared of theta. The second term is 1, and the third term is 1 over sine squared, which would be the same as cosecant squared of theta. So this is the third of the Pythagorean properties. Notice that on our first one we have cosine squared plus sine squared equals 1. On the second two, the 1 is with one of the squared terms. On the other side of the equation is one of the reciprocal functions by itself. Notice that tangent goes with secant and cotangent goes with cosecant. And all the terms are squared. Now let's just check out, does this work? Do these make sense? So on a calculator, let's just show ourselves. Basically what we're saying with the properties is no matter what I put in for theta, as long as it's defined. Okay, so we know, for example, that cosine or tangent of 90 is undefined, so I can't use 90 in this particular equation. But as long as that value is defined and in the domain of the function, this statement will always be true. And it doesn't matter if I'm in radians or degrees. It doesn't matter what kind of crazy angle I use. So I'm in degrees right now. So I'm just going to type in one of these properties. Cosine of, I'll just make up an angle, 67.3. And to square this on your calculator, you're going to put the squared outside the parentheses, plus sine, I have to put in the same angle to make this work, to be true, squared, equals 1. Okay? No matter what angle you put in, no matter whether you're in degrees or radians, this statement will always equal 1. So let me switch over to radians now, and let's do one of the other ones. So how about 1 plus tangent of, let's put a negative angle in there, negative 0.345, okay, squared. Okay, so there's 1. Now that's supposed to equal secant squared. So secant of negative 0.345 squared, they're equal to each other. And you could put in any angles you want, and those will always be equal to each other. Now these are going to have to be committed to memory because these are basic properties that get used many times when we start talking about other properties. So these will be your first memory quiz to write down these 8 properties.